All right, going to take a look at problem 7. It says a 2-kilogram melon is balanced on a bald man's head. His son shoots a 50-gram arrow at it with a speed of 30 meters per second. Arrow passes right through the melon, and then the arrow comes out with a speed of 18 meters per second. Can you find the speed the melon has as it flies off his head? So let's go ahead and draw a sketch. So let's see. Sure. So here we go. Oh, the marker's not so hot. Here we go. Okay. Fringe of hair. All right. Bald man's head. Melon. All right. And we have an arrow that's going to come flying in from one side. Right? It's going to go through the melon, and that arrow is going to come out the other side. Going slower. Let's see here. All right. You see, when that arrow comes through, it's going to shove on the melon, and the melon is going to go flying off at some speed. Okay, so we're trying to find that speed of the melon at the end. All right. They tell us a bit of other information here. They tell us that the let's see here. This is 2 kilograms. They tell us that the arrow is 50 grams. Now, right away, we're going to convert from grams to kilograms, right? So 50 grams, we say that would be 0.05 kilograms. We're going to move 3 decimal places. That's 1,000 grams in a kilogram. And we notice as it starts off, that velocity of the arrow at the start is 30 meters per second. And we know that it comes out the other side of the melon, the velocity of the arrow at the end is only 18 meters per second. So there we go. So thinking about it momentum-wise, right? Arrow has some momentum coming in. At the end, that arrow's got less momentum, right? It's going slower. You say, where did that momentum go? It got transferred to the melon, right? We're gonna make our system. So I think it makes sense. And again, what we're trying to find here, trying to find that speed of the melon at the end. So I think it makes sense to make our system. Clearly, we've got a bunch of information about the arrow. We're trying to find out about the melon. Maybe I want to use the melon and the arrow together because then I don't have to worry about that impulse, right? If I just look at the melon, I have this impulse from the arrow. I don't know the force of the arrow. I don't know the duration, the time in which it acted. So I want to combine the arrow and the melon together as my system so that force is inside, right? So it doesn't show up here. I would have equal and opposite impulses on each other. They balance out anyway if I try to do a combined system. So I don't have an impulse. That's going to be the best way. Now, if my system is the melon and the arrow, like what forces do I have here? See, well, gravity's going to be pulling down, but during the time it takes that arrow to go through, right? That force, the gravity, is going to be relatively weak. It's not going to act for very long. I don't think it's going to have and more importantly, it's going to act vertically. I'm interested in the effects on the horizontal speed, right? The horizontal momentum. So I don't need to worry about the gravity force. I don't need to worry about the normal force from the head. The only thing I might think about is friction between the melon and the head. But we're going to assume that this is a pretty low friction surface, and so we're going to ignore that. So I'm going to have no outside impulse if I do that combined system. But I have 2 things in my system, so I can talk about the change in momentum of the melon and the change in the momentum of the arrow. All right. If I do this, that'll be P melon final minus P melon initial plus P arrow final minus P for the arrow initial. Right? Any of those terms 0? Well, yeah, the melon starts at rest. So that initial momentum of the melon is going to be 0. So I think that's it. That's going to be my terms. Let's go ahead and substitute in mb for momentum. This will be the mass of the melon times the velocity of the melon at the end. And you say, hey, that's good news because this is what we're trying to find, right? And you say, momentum of the arrow at the end, that's going to be the mass of the arrow, velocity of the arrow at the end, minus mass of the arrow, velocity of the arrow at the start. Okay? And you say, yes, I know this, I know this, I know this, I know this, I know this. I know all those values. I am all set to plug and chug in. And that is going to be this problem. No, that's not going to be bad. Was that really all they wanted me to find? Yeah, that was it. Okay, that's not going to be bad. So if I go ahead and put in my values, what do we got here? Mass of the melon, that was 2 kilograms, yeah? 2 times V melon final plus the arrow, 0.05 times the velocity at the end, 18, minus mass of the arrow, 0.05 times the velocity of the arrow at the start, 30. Okay, let's see here. Just punch the calculator. Okay, so when I go ahead and do the calculation, right? Yeah. So I'm going to end up with the velocity of the melon at the end to be 0.3 meters per second. And that's my answer. Oh, that was quick. That was problem 7.